My name is Brian Brady. I work at Ferris State University, and so what I teach is engineering technology. So I want to look at where I want to go with prompt engineering and using AI in a programming classroom for these non-CS type students. So mechanical engineer with a master's degree, 15 years industrial experience before I started teaching at Ferris, and I've been here now 18 years. Time just flies by. The class that we teach in engineering or engineering technology, when you have a programming class, it seems like it's been around forever, that you have a forever, since the 70s or 80s, you'd have a programming class in an engineering situation. And we're not trying to train our graduates to be professional programmers. And sometimes we can lose sight of that, especially if it's a CS type of person who's teaching it. And so we teach our own class, and I teach that to our third year students. And so we want them to know that programming is there as a tool for them to help solve problems, automate systems, processes, things like that. And we know our graduates are going to encounter lots of different devices, machines that rely on various types of programming. And so to be able to look at the code and say, I can decipher what's happening here. I need to make a minor change. Somebody's asked me to do something different with this machine. So maybe I can do that because I have a little bit of confidence and I know what code can look like, or to automate aspects of their engineering. And so the class that I teach, we use Python, some circuit Pythons so that they can get their hands on microcontrollers, and the students usually find that the most fun of the semester, and turning lights on and little motors around and things like that. And then dive a little bit into NumPy for some numeric calculus, curve fitting, and matrix and vector operations, and see how they could possibly use that. The traditional way, and maybe I'm wrong in this, but I think this is the way I've seen it, and this is the way I used to teach it. You lecture about some groups of commands, particular methods, show some relatively simple, sometimes maybe get into more complex scripts. Students are assigned a bunch of practice problems to write scripts or snippets of code that they need to submit. And you hope that the students are doing their own work, and then you manually grade those at a due date. And if you really want to add to your workload, you can provide, after you provide feedback, maybe let them resubmit it, and now you have another due date and you have more work to do. The improved way, and I loved it when I ran across CodeGrade. So now I can build the automated tests. That's what probably most of the people who are watching this at the presentation today are using CodeGrade for. And so you're putting together the blocks of automated tests, even if it's just input-output tests. And now the students can get their feedback immediately. No, I passed these tests, I should be fine. Now, maybe you're doing other tests after they've submitted and they're all done, or after a due date. I let my students submit as many times as they want to up until the due date. So if they find that they've done something wrong, fix it. And I give them all the tests. So they submit it and it runs through all the tests, everything that I want to check. So I'm looking at not just the expected output, but what methods. We've lectured on using while loops. So I want them to use a while loop. And if they didn't use a while loop, I'm going to flag that. And so now they need to go and change, say, oh, how do I do that? They used a for loop, but instead, or they somehow did it without looping. I want to look at the structure. I want to see, did they set up their print statements maybe for the number of decimal places I want to see, whatever it may be. And then it gives them that feedback and they can go back and fix and resubmit. And students have really appreciated that. I have gotten feedback from the students there. So the improved way, right? We have a student has the submission, so they can create their submission. They maybe write their code offline, or they write it right here in the code editor. They've submitted that. They see they get all the check marks on the test that you say run with, right away as you run. And then they say, okay, I'm going to hit the submit button. And then they find out if they passed everything. And once they do that, they expand on it if they had anything wrong, and they see what was going on, right? So nothing new here if you're using CodeGrade. So the new way, I guess, would be to add the prompt engineering and use AI. So Students are going to use it, whether we want them to or not. We can't keep an eye on them 24 hours a day, 7 days a week. If you have any assignment that's being done outside of class, or even if they're doing it inside of the class time, what are they going to do? They're going to pull out their phones, and unless you can keep a really close eye on them, they're going to use AI tools. This is the new future, right? So if we think of that AI as a tool for an engineer, much like for an engineer, programming is a tool. It's not our end goal to be programming. Our goal is to make a machine run a certain way. Our goal is to automate a process. Our goal is to calculate something that might be more complex than we want to do just on pencil and paper, and then be able to do those calculations over and over again. It's like change from slide rules to calculators, to graphing calculators, to programmable calculators, to computers, to applications in our phone that can do all the work for us. And if we're not doing that and having students do things maybe the old way, they're going to get out into the working world and they're not going to have seen maybe better ways or proper ways or more creative ways to use these tools, and like AI. So I want the students to leverage AI writing their scripts by creating better prompts. What do they include in the prompts? What don't you include in the prompts? And the challenge becomes, and I think for all of us, how do you do this, right? It's going to require that you change how you're teaching the course and how you create the assignments. And that's going to be the biggest challenge for me, is how do I create the assignments that students can't just copy and paste and AI does the work for them. So my plan, and so mine's a spring course, and so this is going to be all new and implementing CodeGrade's AI right in the course this coming spring, is keep those lectures in there. Lecture on all the fundamental things that I lectured on before. That will not change. It will be after the lecture how we go about doing the assignments. There's lab time for my class. So part of that lab time is demonstrating prompt engineering to create your code. How to use and write test cases, which we haven't done because we focused more on writing these short scripts and functions and so forth. That just to understand the basics and demonstrate that you can do that. So now, if I write my descriptions differently, and what I think here is I'm going to need to provide less detail and let this engineering student be the engineer and let them use coding as the tool versus me giving them more and more coding type of hints. I've tried out at this point using VS Code and GitHub Copilot, and it's worked great. Same with JetBrains, PyCharm, and Copilot, and using it as the chat interface, and they also have the commenting type interface. And I think this is a good way to do it if they're offline with it, and then offline being not in their CodeGrade, but in CodeGrade they'll be able to use the new AI. And then with CodeGrade, it's not exactly an AI as we know, an IDE. I mean, maybe we can get closer to an IDE and be able to run and then see actual results there before you would then say, oh, run it using the tests. But hey, we can dream. So here we'll write the prompts and get that information back. And I do like the 3 different types of AI setups. I was playing with that a little bit more yesterday. So for a conference that I was recently at, I was showing them how easy, if I say, hey, create for me a script that prints the conference name with ASCII art and make it slanted and use a particular library. And it was like, oh, perfect. I can incorporate that right into the program that I'm writing if I'm writing some larger program. And it showed how easy it is just with 2 sentences to get some output. I also use GitHub Copilot via comments, to do something similar. So I wrote the comments, write a script, make it slanted and so forth. And then if you haven't used the Copilot, I recommend taking a look at it, because once you finish that last comment and add a space, it gives you in a lighter colored text, here's your code. If you want to keep it, hit your tab key, submit it, and you're all done. And these simple code assignments like these are really going to be too simple for AI, and the student's not going to be left doing much work. So there's going to be room to add some complexity. Code check has these great little code script stubs, right? Some comments and say, hey, given this input, this is what we want you to do. So it's seems like a fairly simple prompt that there's not much there. Can AI do that? Well, I find that if I wrote that out and said I want to do this, same this particular stub, and I find that it did a fairly good job. It didn't pass their tests because of one particular thing that I didn't notify AI about. I've got that arrow there, and that is they're expecting a particular input string variable format, and I didn't tell it that, and so it wrote using input underscore string, and it wouldn't pass. As soon as I went in there and changed that one little thing, it passes. So these very simple code assignments that you might give might become a thing of the past, or you can quickly get past them as you have the students learn just how to do the prompt engineering. So if I change my initial prompt and added it in there and saying that assume that that input str variable has already been assigned in the script, it got it right the first time. There was nothing else for it to do. So a little bit of engineering in the prompt, and it was able to get there. So we've probably all played around with it to see that it's too smart for our typical entry-level coding assignments. We need to do more or do things different in some way. So my thoughts is we want prompt engineering to allow the students to focus on solving the problem, not just dealing with problem syntax. I've had students tell me, I worked on this for an hour last night and I still couldn't get it right. And I went in and showed them where they missed a colon. And they said, that was all it was? Yeah, that's all it was. So the syntax is where they got stuck. They essentially had solved the problem correctly. So maybe moving on to more complex assignments earlier is something we'll be able to do with AI. John Johnson once said, first solve the problem, then write the code. I say, first solve the problem, ask AI to write your code, make sure that it works as expected, and then can you read, understand, and explain the code if somebody were to ask, might be our better task for this, okay? So I'm looking at assignments where I'm calling them sketchy assignments. They're less detailed. What I want is not as much detail and giving hints on what you should do with the code. AI is going to do that for you. And I want those students, these are engineering technology students, to lean against the classes they've already had, the engineering classes, the math classes, the physics classes they've had, and go back and reach back into that knowledge or look and find the right formula, but plan a method. What's the method they want to use based on these sketchy assignments? And in order to keep students from just copy pasting or using AI reading what's on their screen and turn it into text, that might have to be back to handwritten paper assignments on green engineering paper. I don't know. But for instance, here is a very detailed, maybe overly detailed. Those of you that are CIS people might have said that I would have never given an instruction like that. I don't know. I'm an engineer. I'm not a CIS guy, but I'm telling them that what I want them to do, make this rectipolar XY and some detailed information in it on what I want them to do, because I'm trying to teach them to write the commands. But if I shift towards teaching them to write the commands to solve a problem, the new instructions, I've got a sketch saying, hey, this is what I want. You're going to make this rectipolar XY, R and theta's in degrees, but it's a handwritten, hopefully legible enough for the students to read. I don't want any rounding, so I don't have as much detail in it. I do tell them I want a doc string and what I want in the doc string, and then here's a sample on the bottom of what, when you run this, so once you import it from the file you're going to give me and you run it at your prompt, what you should get for an answer. So now the students are going to have to take that and run with it and decide what I can do. So if you were to say, well, this is a simple assignment. I'm going to run this one straight in CodeGrade. I'm going to click on the assistant and pop it up. In the assistant, I want them to create I started out really simple, like see how this works. So the student says, create a function that converts X to Y to R to theta for me. They gathered that from my sketchy instructions. And certainly here it is, and it runs it through. I love how it gives the explanations along with it, what's happening with the parameters and the various functions it's using. And then an example use case even, and some output. And then I noticed by reading through it, and we would see if the student would, but that theta is an angle in degrees here. Well, it started with an angle in radians, and I asked hey, can you return that in degrees instead? So we're using degrees in our class, maybe, or we want to in this particular case. And certainly it was able to make that change. And after making that change, it's given me the output in degrees. It even put the degree symbol in there, which is nice, so the students can see they can do that type of thing in their print statements. I was able to then ask it to return the angle from 0 to 180 or 0 to minus 180. All right, or I could have even said from negative 180 to positive 180. And it said, certainly we can do that, because it was doing everything in 360 degrees. And when I was all done, if I hit the run, I see that it ran and passed all the tests. When I would hit the hand in, the only thing that failed is something that the students need to do for me every time, and that's run it through black or something else to make it pass a Flake 8 test. It failed the Flake 8 test, so I told them what to do. I love this. So they went in and they can fix that solution. So me as my demo student got an A and a star on that assignment with maybe 10 minutes worth of work. And maybe that's the size of a chunk of time we want for these small intro assignments, and provide more of them. Okay. Similarly, when I was using PyCharm and using comments, so here I was asking them to find the volume and surface area of a conical frustum. The assignment description for this one is going to tell them to find a formula for a conical frustum, or maybe double check the one that AI gives them if they were to run this. And so in this case, I didn't tell it what the formula was. It came back and it told me I could double check that against a trusted source, and my conical frustum function worked. I've looked into some problems that might be good problems for dealing with AI and this prompt engineering by these promptly problems. Found that in a paper, and it was kind of nice. It gives you in this case, five cases where this a range function was being used and telling you what you should get as the output. So now the student has to do the thinking and the engineering on what is happening so that I can create a prompt that tells AI to give me what I'm after. And so that's something, and then possibly have some points associated with reflecting on this. But I've given them some hints to ask themselves what's spaces and non-letter characters, what's happening to those, what's happening with the uppercase versus the lowercase, making them think and kind of maybe aiming them in a direction without giving away the whole thing, right? So this big shift is going to happen, I think, in entry-level programming and how we teach it, and trial and error is going to be a big part of it. And then that's what I'm going to start as my trial and error period here in January. One is this writing good prompts, setting context to the script, some basic requirements in the first prompt. In this case, I reviewed and ran the generated code and see what it gave me. I find its explanation here. I requested some changes to it. So this was a function where I wanted them to use it was a low-pass Butterworth filter, and I wanted to plot what the filter profile will look like, and then give some statements on particular frequency settings for a number of filter levels. So 1, 2, 3, and 4 in this particular case that I ran. So it's summarizing it so I can read those summaries and see what's happening, review the code after it ran, and I'm hoping that this is what we'll have our students do, but walk them through problems like this. I didn't particularly want a feature that it used, so I asked it not to use that feature. It made some changes. I reviewed the code, made some more minor changes to meet the assignment requirements that I would have, so taking it a step at a time. Again, in order to pass my autograder, I know I needed global fig because my autograder has to look at the actual figure and then pull information out of the figure. So I needed to work after they finish running the function, generating my code. Forgot that I wanted it to print the lines, what I wanted them to look like. And in the end, it was able to create the plots that I asked for, as well as the printed output that I asked for. So this is going to be a more involved problem for a student to prompt what the instructions look like. I'm not exactly certain for this one yet, so that I don't give away the answer to begin with. It may be that it's, here's what your output will look like, and then a few pieces of information, and then let them get to there. I will still need them to know which order I want the plots in, because when I go in and look at the figure, the code that I've written, I need the 0th item in the figure to be a certain line, and the number 1 item another, and the number 2 item to be something else. And so that's where I'm going with it at this point in time. And there will probably be more and more changes, but that's what I have. So I'm going to stop the presentation there, because I don't want to steal any thunder on the different prompt types, even though I was looking at those and really excited about them.